Right, good evening everyone and welcome back. Welcome to 2022. Let's do some live stream things. It's been a little while. Some things have happened. There's been lots of video things going out. After kind of doing loads of streams, I've now done like a few videos all in one short go. Well, not that short, I guess, but anyway. Today we're talking about these two printers behind me, the Ratrig V-Core 3 and the Voron 2.4, and it's like a question and answer session mainly about them, and when we're done with questions we'll talk about mods and things like that. So, yes, hello everyone and welcome back. So I've got some like pre-made questions, but if anyone has questions straight away. When are we getting a Voron mods video? Yeah, so there is mods. There's a bunch of stuff over here which you sort of can't see. There's some mod things planned. It probably won't be a video, it'll be live streams of assembly stuff. I might do a video at the end to kind of summarize and see how it all went, that kind of thing. But largely, that will probably be a stream format when it does happen. I'm getting everything ready and it might take a little bit, but eventually we'll get there. Is audio low for everyone? What's it like? I think it should be the same setting I'm normally on. Maybe, I think this might be different. Might have changed the decibel level on the decibel metery thing. How about that? Is that more? That sounds like it might be peaking now. Oh no, that looks like it could be okay. As long as I try not to shout. Much better, excellent. Yes, it needs two different levels. I have one level for the camera and one level for the live streams, and just remembering to change it over can be a little bit difficult. Oh, we have a question. From a 100-foot view, that's like pretty high level I guess then, what's the largest difference in quality of light and how is RatRig's implementation of Klipper? The idea of the music is it should just be background, so you hopefully can't really hear it over me. But when I don't say anything, you should be able to maybe just hear it. That's sort of its purpose. There's all sorts of different... The biggest quality of life difference is probably... Because I've not got the Klicky Probe on the 2.4 yet, the probing sequences and stuff on the RatRig work much better, but that is just because it's like a temperature sensitive probe, and the Z doesn't probe the bed, that's only for the gantry leveling. So it tends to fluctuate a little bit too much. So that I've got all the parts for Klicky Probe. Also firmware configuration. So because RatOS basically does like all the difficult things for you, the firmware configuration for that is just like, oh yeah, I have a V-Core 3. Okay, that's firmware configuration done. It's really, really quite easy. Are you doing a VZBot build or review? I haven't got a plan to do that at the moment. it's more about what I'm approached to do sometimes, rather than what I just want to do. I've still got loads to do on these, and I think extrusion force testing, as you might have guessed from the recent video, might be a lot of what I'm doing in the near future. There's just an enormous amount that can be done with that. So yeah, I'll probably it'll be mods for these first, and then we'll see where we get to with live streams. There's already a live stream set planned for one little printer, and maybe an upcoming another printer. So we've got some little printer stuff as well coming, which I'm pretty sure you'll enjoy too. The Voron is enclosed for ABS. Yeah, if you're printing, well, it's not, I wouldn't say it's for ABS, but it's for anything that tends to be a little bit more warpy, or so things warp because they cool down too much. So you increase the ambient temperature so they don't cool as much sort of after you've printed that part of the print or those layers, because it's that constriction that causes everything to kind of fold up. So the enclosure just keeps the ambient temperature higher. So yeah, ABS or anything higher temperature than that tends to be a little bit warpy. It's useful, that kind of stuff, but it's not a heated chamber as such. It is just some panels on the outside, so it can get pretty warm if you don't have a fan or anything on the back. Mine got to around like high 50s, maybe touching 60 degrees Celsius, which is pretty warm. But it's not like hot, like it's not burn yourself hot in a short space of time. It's just like a very high ambient. Yeah, it's not, they're not really designed for like heated chamber printing. It's just prevents any airflow through it and just helps with warpy things. Oh, the green. So these mod parts I printed on the V0. And it just happened to have the green in that I had still when I did the first print, when I did the LDO Motors kind of build stream for the V0.1. So yeah, that's why there's a bunch of green bits. And then the black bits are parts that I printed as part of the review. So I ended up with 2 sets of all the Klicky Probe stuff in black, just because it was useful to print those parts. And so I've got those all ready to go. The actual parts that will end up on the printer are all black. It's just like the tools and template stuff. There seems to be quite a few bits. I think I've double printed some things, but it's better to have 2 of things than none of them, especially when you're trying to do a live stream and you can't just like whiz it off the printer in 10 seconds. I'd like to see a RatRig minion. Nobody has builds up yet. There are some small printer things coming. Will you be enclosing the RatRig in the future or leaving it as your open printer? So I'm planning to enclose it. And there's a lot of other things I want to do as well. There's a big mods discussion for the V-Core 3. I'll show you very quickly as a teaser, and then we might talk about it later on if we get a bit more time. So here you go. That's a V-Core 3. At least it's made of V-Core 3 parts, plus some changes. Is it worth to use Duet on the RatRig? Personally, Duet is amazing. On the Extrusion test rig, I've used the Duet 2 Wi-Fi there because it's just super versatile and you can kind of do what you want. It's a control board for 3D printers, but it's mainly like a control board that can do anything. And that's generally true of control boards anyway, but it's very easy to just kind of play about with that. So while it is very powerful, it doesn't actually have input shaping like Clipper does. The last time I looked, which is like after I finished the build, they were just implementing a beta stage of input shaping. It looked promising, but it didn't look amazingly kind of polished or finished. It was a beta, it was not finished. So at the time, and I was getting Octopus control boards from Big Tree Tech, so you know it made sense to do that. Personally, I think given the amount of community support and stuff on Octopus, especially with the RatRig, I'd choose the Big Tree Tech Octopus boards over the Duet for this specific printer in this specific scenario. Unless you're maybe planning to do like loads of weird modification stuff yourself. And I mean like really weird, like loads of extra axes or something weird, I don't know. Generally, you might as well stick with the Octopus. You can still do a lot of that stuff in Klipper. A lot of the firmware configuration on Klipper and the Duet firmware, RepRap firmware, is kind of very similar. The big difference is that Klipper uses kind of text to describe everything. So when you look at a command, you can kind of read it and you know what it is without having to look things up. Whereas with Duet, the downside is they've kind of shortened everything. So it's like a G-code command with just like a P20I6J4. You're like, okay, that's a command, but what does it really mean? You then have to go and check all the references and double check everything every time you look through it, because nobody can remember all of that. So it's just a little bit easier to read the Klipper stuff, but generally I think there's a lot of similar things that they both can do. Have you chosen a colour yet for your V-Core rebuild? Are you going to reprint them in a different material or stick with PETG? So when I do RatRig, they are all going to be ABS parts because it's going to be enclosed, and the heated bed, especially with these arms in particular, like mine's actually all ABS now anyway, but these arms in particular are pretty close to the bed and in an enclosed space. Potentially get a bit warm. I don't know, it's probably not that bad really, but for me, there's no reason not to use ABS, given I have, well, one printer very capable with ABS and one that's becoming very capable with ABS, and the little V0.1, which for small parts, obviously, again, very good with ABS. No reason for me not to. This is colour scheme. I thought I'd go with like, I guess Vector 3D colours. I think so. Most of it's going to be black, and then there'll be a bunch of yellow accents scattered around. That's the plan. So all black and yellow. I think it's going to look pretty sweet if I ever get around to doing it. I'm sure I will at some point. It just might be a while. How hard is it to find stepper drivers that support 48 volt power supply, and is it worth the hassle for the upgrade? That's a really good question, and one I'm not really sure of. So the theory behind using 48 volts, which is, I think the Octopus Pro is like the only one that commonly supports that at the moment. I think the Duet 3 can support high voltage as well. Don't quote me on that, don't just do it. But like the idea is you can get more torque out of your stepper motors with high voltage. So in theory, you could get better stepper motor performance, specifically if you're going to try and print at ridiculous speeds. I don't think we're really hitting limits for most people on 24 volts. It seems to be serving a lot of people very well. So I wouldn't say it's something you need. In terms of stepper drivers that support it, I believe the TMC, I think it's their like 5000 series, so like 5125 or something I want to say. If Mikkelson was here, he might be able to tell you, because I know he's used one or using one. If you look for the Octopus Pro and the supported stepper drivers for that, that should help you. They're not rare, I don't think. Like, they're not difficult. Duet 3 is 32 volts, yeah, so it's more than, thank you James, it's more than the standard 24, but it's not quite the 48 of the Pro. Octopus Pro. My chain's at 52 and the bed has only been on for 30 minutes. Sounds about right. I normally wait maybe 15 minutes or something before I start printing. It's not up to temperature, but it's enough that I'm confident that by the time it's done the first few layers, the chamber will be hot enough that it's not going to then cool down too much. Because while it's very close to the bed, it's probably not going to cool much anyway, because you've got a lot of hot air, obviously, by the bed, which is at 110. Have you had any first layer issues on RatRig? I'm not sure ABL is particularly good. Not really, no. No, first layer performance on RatRig's been really good, actually. It reminds me there's some parts on there, which I don't want to show at the moment. I don't think you can see them. It's fine. No, I've not really had problems with that. What I have... No, it won't be done anymore. No, I've not had problems with it. It's been really good. If you are having problems, it might be the BL Touch wiring. So that, it seems to be quite sensitive to electrical interference. And that can be a big problem when you're running a lot of wires in parallel between the kind of hot end extruder, the carriage, and your electronics compartment. You've got, as soon as you're running a lot of wires in parallel like that, they tend to get lots of crosstalk, I believe is the correct term. And because BL Touch is seemingly quite sensitive to that, it could be that that's causing your values to just wander, which might cause some dodgy results. How was the LDO 0.1 kit? As a kit, very good. Yes, my biggest pain point, which I think is pretty common across the board, is that the little nuts in the V-slot, it's not V-slot, in the extrusion, there's no way to stop them sliding. So it does take a long time to build, and I think most of that is just aligning the blooming nuts in the extrusion. And then as soon as you take the paddles off, all the nuts just fall down, and you have to realign and turn the printer over and put them all in place. Oh, it's a nightmare. But there is a mod for that, and I wish I knew before I started my build. There's like some little printed nut carriages. If you look on the Voron mods page, you should be able to find it. I think if you just look for nuts on the Voron mods page. And it's just kind of a little printed carriage that you press a nut into. It kind of bends it a bit, the printed part, and that forces it to have some friction in the slot. So as you push it in, it then kind of stays in place, which is exactly what you want. So if you are building one from a LDO kit or otherwise, I would recommend that. The rest of the kit, really rather good. The one thing I have had a problem with, what we'll cover, I'm actually going to be doing some upgrade series on it. So that's a little printer thing. The X carriage rail on mine, for some reason, it has like the tiniest amount of wobble. And it's because the rails that are used are very small. So the carriage has a little bit of vertical movement. And I think as it's pulling filament, it can pull the carriage up and rotate it a very tiny bit. It's like literally a fraction of a millimeter. But obviously, when you're only doing layers that are 0.2 millimeters high, a fraction of a millimeter is quite a big bit. So I've got some other rails to try out. Everything else on it is absolutely fine. It's just that one rail that seems to be not quite perfect. I would quite like an IDEX or some sort of multi-material. Oh, hang on, we've got, I've skipped down a bit. I haven't considered that I'm now going to be talking for like 2 hours. My voice is going to be dead. I've got some water. I might have to try and talk a little quieter. It's going to be ASMR live streaming now because I've been shouting, which I tend to do. Have you had problems with the Mark 52 bed, which is a bit sensitive and burns out? Mark 52. Oh, that's what they call the Prusa one, isn't it? No. I think I've had the same bed on my Prusa since it was brand new. It's not really a Voron or RatRig question, but there you go, there's the answer. Is an IDEX printer next for you to construct? Yeah, I've still not ever, can you believe this? I've not done any multi-material printing at all. Like, I've done the thing where you like stop it at a layer and change the filament and then it carries on, which I guess kind of counts, but like nothing that does it on its own. You have like proper multi-material or multi-even coloured. It's just normally like some letters on some background. It's like as far as I've gone with multi-material printing. So yeah, something that's IEDEX or tool change, that kind of thing would be really interesting to do. I know Prusa XL is going to be that sort of thing in it. Very pricey, not pre-ordered one though. So given how popular they're probably going to be, and I've not ordered one at this point, I doubt I'll be getting one in like the first year or something that they're out. 48 volts can get you more torque and more speed, but it can also get you cooler running motors at the same torque or speed. Yes, yeah. 5160, I'm a long way behind in comments, aren't I? Which wires have you used for the RatRig? I'm not quite sure what you mean by which wires. All of them. I've used all the wires. I'm not sure what the question is. Maybe you can ask again if you can clarify a bit more. Am I going to build a stealth burner? Someone's probably already asked. No, nobody has asked yet. And yes, I do want to. I've not actually printed parts of that yet. But I should be able to get all the bits I need and print all the things, and then we'll be able to do one. So yes, I do want to do it. It will be a thing. That is part of the plan, definitely. For anyone that's just joining, we're doing a bit of a Q&A on Voron versus RatRig. Not that you should like, they're not as like competing, it's just any questions based on the video and stuff that I did on these two printers. This one's obviously rotated, this is the side, and this is the Voron, this is the RatRig. Better to buy a Prusa i3 or a Voron or a RatRig? Oh, my friend, they're very different things. A lot of people have asked me, like, which is the one I'd buy, and for me it's always, it depends what you're buying for. Like, what are you trying to do? How big do you need to print? There's a lot of things that go into what decision one would make, be it me or someone else. I think it's important that you understand what you're trying to do and what you think you'll enjoy of it. If you hate the idea of building something, then you might not want to get a Voron because it's only in a kit. Same for RatRig, it's only a kit. Isn't there? Yeah, they're not sending them pre-assembled, are they? No. So, if you like the idea of building, all of them have kit options. But Prusa can actually be purchased pre-assembled. Prusa is a bit more limited on print temperatures and enclosures because while you can put a box around it, all the power supply and motors and everything are within that volume and not necessarily designed for the higher temperatures. There's loads of reasons. Are you using PTFE as your enclosing? Lord M asked, that was Lord G. Which wires have you used for the RatRig? Using PTFE as if you're enclosing. I've not used PTFE wires, no. I've just used the standard wires that come attached to all the parts and that kind of thing. There's nothing special about the wiring on the RatRig. Oh yeah, so no, I've not done anything really special with the wires on the RatRig at all. I used, because I was building the kit as it came, I was focused on using what was included rather than modifying it. So there's nothing modified really on the wiring other than maybe some cable management and the electronics panel. Generally it's not far from its stock design at the moment. It would be really nice to get some drag chains, but they're not going to be as easy to do as I think they are on the Voron. We'll see. There's plenty of options. My thoughts on the LGX Lite? I think I don't have one, so I can't say. Are you still planning on doing the open front RatRig mod? Yes. We'll talk about that in a bit. Do you like the Dragon High Flow hotend? I'm building a 2.4 but can't decide on a hotend. Maybe I should wait for more of your testing. Yeah, the testing's cool, isn't it? The Dragon High Flow that I have on the RatRig is definitely doesn't seem to be as performant as the one in the Voron. That one was an early sample, so it could be that the geometry is a bit weird, different. And I'm not sure, I don't know exactly what, I mean, now we've got this force testing rig. Any prior knowledge I thought I had about flow rates is sort of, I'm just less confident in it. So while it should be a very high flow hotend and good performance, I've not tested it myself yet. So it seems to be fine. I've not had any problems with it. I can tell you that. With the normal profiles, the PIF profiles from Doc, prints, ABS and stuff, all fine. So I wouldn't worry about it. Just make sure you keep your enclosure less than about 50 to 55-ish. Because if you go over 55, it starts to, the air cooling is not enough to cool the cold side of the hotend with this design. If you have stealth burner, maybe it is. I've heard it's better at cooling. But yeah, is that enough information? Hopefully that answers the question, kind of, a bit. Do you see the Revo Voron design, the Revo Voron announcement? I did indeed. It's even smaller than this. It's absolutely tiny, and it has a rigid mount. Yes, at last. You run a standard flow Dragon with a CHT and get 24 cubic millimeters a second. But what quality of 24 millimeters cube per second? What is the extrusion force? We must know this. Got some of those too, so they're pretty cool, aren't they? Hopefully get these in the test rig at some point soon. I've had a quick, very brief talk with Stefan about, well, I've not talked, I just messaged him about potentially, well, he's looking at building his rig or finishing off his rig and doing some testing, so there might be some more comparison stuff there to be had, which would be interesting. But even on the test, we're not talking testing, we're focusing on this today. Ah yes, the story of the 500 by 500 RatRig that you can't fit through a doorway. Yeah, I don't think you're the first person to find that you have to build it exactly where you're putting it, otherwise it can't go anywhere. It's basically the size of a washing machine by the time it's finished. Do you prefer the Voron extruder mount or ever? I've always liked the Voron design. The Voron design does, there's a lot of nice style about it, but there's a lot of nice style to the Ever one. I think aesthetically the downside with Ever is that there's not much management for the wiring. So once finished, while it's very good in that it limits the amount of plastic needed in an effort to keep the weight as low as possible, it can end up looking a little bit messy when it's finished because you can see any of the wiring that's around the hot end area, which is not like bad in terms of performance or anything like that. It's not going to affect your print quality. It's fine. There's nothing wrong with that. But just the overall aesthetic when it's finished, that just looks really tidy and very, I guess it just maybe looks more professional because it's all tidy and kept and looks very well finished and well polished. From reading in the Discord, it seems like a lot of the SSR fail closed. Is the live stream going wonky? Hopefully not. From reading in the Discord, it seems a lot of the SSR fails closed. I was thinking about replacing it with a Variac since it should be able to handle the many open off switches better. I'm not familiar. Isn't Variac like a variable? Yeah, I'm not sure, but I don't think that's going to be appropriate. A solid state relay is the right thing to use. As far as I'm aware, I'm not an electrical engineer. But as far as I'm aware, it's the right thing to use because it's a digital switch. Well, it's a solid state switch. There's no moving parts. It's capable of the high-speed switching needed for PWM without wearing out. I don't know why people have had trouble with them failing closed. They do have a tendency to fail closed, but I'm pretty sure you can get some that do fail open. I thought that was what was specified in the Discord, in the Voron bomb. Yes, I'm pretty sure you can get them that fail on. Can you lubricate the RatRig rails without sliding carriages off the rail? Yes, yep, you can lubricate both printers completely without sliding anything off the end. Because they have linear rail carriages with a hole in the end, what you need is the pushy thing, the syringe, and you can get metal needles, which are just plain stainless steel tube. Obviously you don't want the like surgical incision point on the end. It's just a flat tube and it's for lubrication purposes really. I can't remember exactly what the sizing is at the moment. I think I mentioned it in the video. I might have cut it out. If you can find the right size, ask in the Discord is probably the best place. But yeah, you can do them all, and you don't have to even like disassemble anything like at all. You can just reach around and get access to all of the holes. So yeah, all works pretty well. What do you take from the Voron to the RatRig and vice versa? The bed, I would definitely take to the Voron, and they call that the Trident. From Voron to RatRig, I would definitely take the skirts as electronics enclosure, because I think this is just a lot of material that doesn't really do anything. It's sort of there, but it's right next to this, which is doing the same job. So I think a lot of the heavy stuff back there is not necessary. It would take a lot of weight, potentially some cost, lots of screws away, maybe, depending on how you do it. So yeah, those are probably the best switches between the two. And then the other thing I actually really like about the Voron is the simplicity of the panels. It seems like a really, really basic thing that, like, who cares? But the way they've designed the enclosure as far as possible is to not have to cut the panels any more than just square. Well, not actually square, but to whatever dimensions, the outer dimensions. There's no like extra cutaways and loads of extra holes and like all this kind of stuff. It's just a rectangle of the right size, bang it on, screw it in. Which for the kind of DIY hobby market, for people that don't have access to loads of tools and laser cutters or fabrication shops or all these kinds of things, being able to just use square panels is really quite important, I think. And the RatRig, because of its use of these parts, I mean, you could obviously just slap a panel over the top of them. But in their design, what they have at the moment is the panel all comes around there. So every panel you have, pretty much, you've got these corners and you have to cut everything out around it all the time. Which is not, it's not bad because ultimately the design philosophy is different. Voron is designed to be DIY'd at home. RatRig is designed to be sold as a kit. So if they're selling enclosure panels that are all pre-cut, it doesn't matter, right? That's how you get access to those parts. But when it's designed to be DIY and they're not going to supply you those parts and you've got to find a way yourself, the easiest way is just plain rectangles. So. Are my nails still so nice after building both? Probably not. Are you sure those holes go anywhere? Mine seem to be solid behind the hole in the plastic cover. Mine definitely go somewhere. They should go into the carriages. Yeah, I'm not sure what you've got there. The point of the hole in the, I don't have one that's freely available. Trying to find one I can use as an example. On the very small carriages, like the ones on the V0, 0.1, they quite often don't have holes in the end, which is really annoying. But the size for both of these printers, they should have holes, and those holes are literally the entire purpose of those holes is for lubricating. So if it looks like a hole but it's bunged up, that's a bit strange. What's the Voron span bar? Is that? No idea what that is. It sure seems like RatRig electronics should be able to be moved to external box or enclosure. I'm not sure why you would do that. There's plenty of space for them on the printer and they're well separated from the rest of the printing area, so I wouldn't bother moving them to separate enclosure. That would be a bit redundant, I think. I mean, the entire design is literally designed around making sure the motors are separated and everything else is separated as much as possible from an area of volume you can heat. So yeah, I wouldn't move them to a separate external enclosure, but you can definitely like move skirts to the back, and that's what I've got inside my CAD. Maybe we'll have a look at that in a bit. The RatRig panels would be cumbersome to ship. They would, especially the 500mm squared ones. That's true. But that's when you kind of want them to then just be rectangles so that anyone can cut them really easily. Or just, it's a lot cheaper if you're going to buy them from a shop that just cuts plastic and sheet materials and stuff and sends it to you, if you're just buying a plain rectangle. So I bought some panels today for the V0.1 as spares, just in case I break them, because I've got to do modifications. And like the little square panels for Voron, you buy them just as rectangles. It's like £7 or £8. You buy them with the the holes cut out and the slots and everything on it, and it's like £23. Just that difference. It's like the same piece of material, but the amount of cutting increases to the point where it just becomes very expensive. So the more you can do is just a plain rectangle, the better. Obviously, it's not like always possible. Like even this one, like the bottom panel there, that has cutouts and stuff in it. But all the sides, there's a filter obviously at the back. They're just way closer. So it just either reduces the cost or just makes it easier to do yourself if you're trying to do them by hand, and it just simplifies it a little bit. I have a question regarding V0.1. If build volume is 120 by 120, why is build plate exactly 120 by 120? I don't know, I didn't design it. I mean, technically you can build right up to the edge, kind of. I always thought it was 100mm cubes. But, don't know. I can't answer. I didn't design it. That is what it is when you're buying a printer. I think what the keeping these panel, you can't see very well. Keeping these corner cutouts on the RatRig, I think the best, potentially cheapest option for panels. Oh, the problem is the screws in, isn't it? Oh no, so your panel you would have up to here. So that would work. Your panel comes in here, up to the edge of the screws around all four sides, and then the similar style clips that go into here, and then a foam tape up the middle. It would definitely be doable. A bit more challenging, but probably doable. Good evening, Mikhail. Pavel, I think I already said hello to you, didn't I? I answered your question about my nails. Oh, Mikhail, it's good that you're here now. Somebody asked a question earlier about 48-volt stepper drivers, and I know you've looked at Octopus Pro, so I wondered how easy appropriate drivers are to get hold of, and which are those drivers, because I've not really done anything with that at all, so I defer to your expertise in this area. If you wouldn't mind answering, that would be delightful. If you only had to keep one, which one would it be? Oh, it's quite a clever question, because it's not which one would I buy, it's which one would I keep. It's sort of the same question, but also sort of isn't. Because keep implies from this exact point which they're at now. So the big advantage for me at the moment is I've got an enclosure on the 2.4, and that's the first time I've had an enclosure on a printer, and being able to print ABS reliably, barring dodgy first layer probe stuff occasionally, is really beneficial. And since this is not enclosed, well, it can print like ABS Plus still really well, and ABS, as long as it's not too large. It's not quite as useful as this because of that enclosure. But other than it's still really easy to put one on here, so there's never a simple answer to anything. So Mikhail says, I'm not sure how hard they are to acquire right now. There's a bunch of them at this point. The Big Tree Tech 5160 Pro, 5160s, Mellow 5160. So it sounds like they're probably all based off the Trinamic TMC 5160. I think somebody did mention that one earlier, so. So it looks like something 5160 based is probably what you're after. How can RatRig go all the way up to 500 when Voron is barely able to do 350? I'd say that's probably because the frame is much more rigid. It has really fat extrusions. I mean, you can probably see if I open that. It's quite difficult to see. Yeah, you can see the kind of the extrusion size here, 20 versus the 30-30 here. Area difference in stiffness between 30-30 and 20-20 is big difference. So that's probably one of the main reasons they're able to go larger without any downsides or any major downsides. Obviously you can never print as fast the bigger your printer gets, and that bed is going to be absolutely huge, but still should be fine. RatRig sort of sells enclosures. They're selling that top hat thing, but they're not selling the panels. So, are they? No, I don't think so. I don't think they're selling other panels. 5160s are required, but it requires beefy components on the sticks themselves as well. Do not run regular 5160s at 48 volts. Yeah, it's just not that simple, is it? So yeah, the Big Tree Tech 5160 Pro, Phystech 5160 high voltage, or the Mellow 5160 somethings that are probably suitable for high voltage, and check the details on the description of the page where you're buying them. Hi Nitram, not sure how to pronounce that. Good evening. Yeah, of course there's belt size 2, and the XY belts on the Voron are 6mm, whereas on the RatRig they are 9mm belts, so there you go. I really liked your recent extrusion test video. Great to see graphs. I appreciate all the work it must have taken. Thank you. You're correct. It was a lot of work. Do you think the Trident will be the best of both worlds when comparing the RatRig to it? Trident looks like a pretty good option, doesn't it? I've not seen what Zed's probing situation is with Trident. Presumably Klicky Probe is still a thing for that as well, so I don't know. I just need to get this Klicky Probe on this printer. Oh, sorry. Fiddling with the microphone. Oh, look. I have Vector 3D hoodies, by the way. This stream is sponsored by me. There's hoodies and there's polo shirts. They're both available on the website. If you fancy one. They're really rather nice and comfortable. There's t-shirts as well, actually. So the hoodies are grey, polos are white, and the t-shirts are black. So if you fancy some garments, I've not gone over the top with the designing, it's just the logo, but I think it's clean and it's tidy, and you might want one. So there you go. It's sponsored by me. Weirdly, apparently, it doesn't matter. I'm just going to talk about advertising regulations. I don't think anyone really cares. Have you looked at the Doom Cube? Yeah, somebody mentioned it. It's basically an entirely different printer where the electronics are on the top or something, isn't it? That's what I gathered. It seems interesting. Voron, you don't get a panel either, so you're left to source them yourself on both ends. Yes, you're left. Yes, this is why. So, while both printers you have to source the panels yourself, the Voron ones are easier to sort. Well, they're cheaper to do, or easier to make because they're mostly rectangles. On the RatRig, basically none of them are just plain rectangles, which makes them more difficult to make, or more expensive to buy. I'm yet to see the hotend test video, but I was thinking about putting data like that on the ever pages, but wanted a whichever plus drive hotend combo is the most powerful. You got to see it, Pavel. This is so cool. I think you'll love it. It's like, it's so difficult to describe. Imagine you can stand inside of a hotend and just like measure it while it's printing. That's that's what it's like. It does take a lot of time just to test one single thing, but yeah, I'm planning to try and go through. So, I wasn't going to talk testing. I'm trying to keep. Okay, we'll do a quick. So, the first video was sort of me proving that the rig kind of works, trying to see if people find it interesting, and forcing myself to get results out of it. Because obviously when I started, it was just a thing attached to a thing. Like, what do we actually want to do with this? And now having used it, I've tested it, I've tried it, I've tortured it a bit. I know that there's more things that I want it to do. And I kind of want to do those things before I then test 10 hotends on it and spend weeks doing testing. So I think there's going to be, between now and the next video, I'll test a similar hotend arrangement, but I'll change a bunch of the things on the equipment itself, which allows me to test even more parameters at the same time. Because while it was very interesting, the amount of data I got, it also raised loads more questions. And I'd like to gather a bit more data so I can potentially answer those questions rather than just go, oh, I don't know, looks cool. So yeah, that's the problem when you have loads of data. You then have loads of need for even more data. Anyway, there's an easy mod that makes the sides, front, back easier, cheaper to source. It's basically a printed part that turns the corner plates into a triangle. That should help, yeah. I mean, you almost... Yeah, I mean, just sticking a triangle in there. I mean, you don't even need the printed part. You could just do the panel and cut the corner off. But it would be even better. I think, did I mention this before you were here, Mikkel? I think what you could do, I know you don't do this bit, but, so in general, for anyone, this is what I was talking about. Where's a panel? I just need a... Oof! Ow, just kicked the desk. So, I think if it was... Oh, you can't see because there is the right place. Because you can still put a clamp in there. You could put the foam tape stuff in here, that over there, clip in there, and that comes up to the screws. And at that point you've got... Obviously this is not really the extruder anymore. It uses something different. Extruder? Spool holder. I think that would be a very simple panel design. You just need a bit of foam to fill the gap. It is an extruder tester as well. It's an everything tester. It's a nozzle tester, hot end tester, heater tester, thermistor tester, motor tester, extruder tester. It's just everything that's in that system tester. The downside to that suggestion that I just made with the panel is that it doesn't provide any structural benefit. Swings and roundabouts. Yeah, literally just, yeah. The Doom Cube Discord is a bunch of designs based on Voron printers, IDEX, insulated, tiny, etc. If it's based on Voron, then I probably won't. I guess if it's based on Voron, it's just a really big mod, isn't it? So. Oh, Loz, sorry, something to help sponsor the Q&A. Lovely, thank you very much. Keep up the good work. Looking forward to some projects from you. That's very kind of you. Thank you very much for the donation. I've got no water. Hey, Stephen. The panel is not supposed to be structured. Oh, yeah, I know, but it doesn't mean it can't be. It should help with rigidity, but yeah, it's not needed, right? Like, we all know that it prints bloody well like this with no panels, so. I'm just going to go get some water, but this is not like a super pro live stream, so I'm just going to walk away and be back in a minute. Could you hear that? I do, because I've got the wireless microphone on, I didn't know what the range was. I kind of assumed it would cut out, but I guess you heard it. No. Still in the box. I've not had them very long. And I don't have any nozzles, unfortunately. I've got a 0.4 nozzle on a micro and a 0.4 nozzle on a Revo 6. But I don't have any other nozzles yet. And I won't be getting, I don't think, any nozzles until public availability, unfortunately. Huh. There's other stuff in the bottom. I wonder how many people are actually just going to accidentally throw that away. I think these are just like prototype boxes or OEM boxes. So hopefully nobody, I don't think, considering how fancy their other packaging has been, I think this is just going to be OEM boxing or something. And my guess is their final packaging is going to be a bit closer to the Hemira packaging. Ooh. What the dickens is that? Got a secret surprise in my box. Anyway, Yeah, I will be testing flow. I think that might be one thing I get on the test rig fairly soonish. That and CHT nozzle. There's so much, man. There's so much to test. And it does have definitely more than 10 cubic millimeters a second of flow. The V6 was somewhere 10 to 12 by whatever test methodology they used. This is more between, should be, this is what they told me, between V6 and Volcano, which is definitely then more than 10. Yeah, it's literally just to convert the 24 volts down to 5. Yeah, I know it's nothing, it's nothing special. But it does use a sun-on fan, so that's, I hadn't realised that before, I don't think. But now we know. Are you going to upgrade your 2.4 to the stealth burner? Yes, at some point, probably, maybe. That's the plan. Yep. Yep. The website says 10 for the Revo, does it? Well, if you've seen the video, well, swings and roundabouts, who knows? We'll take a closer look at that. I'm surprised the website says 10. Website says 10. I can't believe they'd make something that's 2/3 the performance of a V6. That doesn't make any sense. I'm looking at their web page now. There's nothing even on the page about flow rate. There's a video. I'm not going to watch the video while I'm streaming. You should perform a GR and R on your test rig. Measurements without knowing the limits of a measurement system are flawed. I'm not sure what a GR and R is, but I mean, I'm not exactly writing papers here. I'm making YouTube videos. Repeatability and reproducibility. Process used to evaluate a gauging instrument's accuracy by ensuring its measurements are repeatable and reproducible. Yeah, so if I just spend 10 weeks doing that study and we don't get any videos, that'd be great. Good idea. On the data sheet. I still can't see it. I must be absolutely blind today. Oh yeah, 10 meter depending on filament, 10 millimeters cube per second for Revo Micro. We'll see. Underestimate, over deliver. Again, it might be they wrote the data sheet a long time ago and hadn't fully tested or something. I don't know. UK cubic millimeters like UK pints. No, a cubic millimeter is always a cubic millimeter. That's the great thing about millimeters. Well, they're not always the same, but they're always very similar. I mean, they can put whatever flow rate they want on it. Like, I'm not going to tell the Voron team what they can and can't do with a hot end. If they want to support an E3D Revo, then they do that. Because that's their thing. New subscribers, yay! Did you see Nero's short he just released today? I haven't. Directly addresses my statement. What statement did I make? Oh dear, what have I done? Oh, it's some measurements. Oh, he's talking to you. Oh, okay. Yep, missed that. Right, so there were some other questions that were generally in comments. We can answer those. The V-Core 3 seems to be better on paper. This was a comment I think left on one of the videos. Do you have any explanation why V-Core 3 has more stringing when using the same hot end, and why its bed is more probing even if it is floating? I'm not sure about the second part, but why is there more stringing on the V-Core 3 when the hot ends are the same? Well, the hot ends are not quite the same. They're like the same. They have the same name. But the V-Core 3 one is an early prototype. Well, no, it's not. It's an early sample. So it should be production, but it may not be perfect. So I think that's what's affected the stringiness, unless I've over-retracted. I didn't think you could over-retract in like a bad way. I've not done any more testing to find out exactly why they're different, but I wouldn't expect it to be a problem. Like it would be, you could get rid of that by tuning, basically. The Revo release will be March, I think, for purchasing delivery. So yeah, I think Revo is a really good option for small printers, especially for changing out to really small nozzles. I kind of want one on my Prusa Mini. I think that's a really good place for a Revo Micro, because it's not after really high flow, but it makes a small printer really versatile and easy to adapt to like whatever you're trying to do. And then you just leave your big printers doing the big printer things that big printers do. Yeah, and even like a Mark III, I mean, a Revo 6 on a Mark III, having that super easy nozzle change. I really need to start using them. Could have done that today. It doesn't really apply to Voron. I really just need to get it in the gosh darn printer, because I really want to start using them and trying out. The trouble is they only give me 0.4 nozzles. Oh, I almost cried when I opened the box. I was like, there's no nozzles in here. It's like, in my mind, like a big part of what makes Revo is having the different nozzles. If you've only got one nozzle, I don't feel like you've gained much. So, come March, I'll get some more nozzles. I promise. I'll buy more nozzles and there'll be more things. But for now, I've just got the 0.4. Unless I make my own. No. Unclog, you just take it out and put a new one in. Yes, Pavel, yes, please. I didn't mention this in the video, maybe I should have done. But I used a very little bit of your Eva for my testing rig. Because I know how adaptable it is. I probably should have mentioned that in the video, shouldn't I? I feel bad that I didn't now. Like the very front, the bit that holds the hot end, I just basically cut out the Eva part because I know it's super adaptable and has options for all the good hot ends. I'll be sure to mention it if I ever do a video on how I made it. Maybe I should add a link to the description. Soz. Most people almost certainly not using the flow rate they think they are. I think a lot of people don't. Oh, I don't want to be rude. But all the, I mean, flow rate and speeds, accelerations and jerk and input shaping, they're not like super basic. Like it's quite technical once you get into the weeds. How is PLA on the 2.4? I mean, I kind of answered that in the video. I mean, it prints PLA. There's no problem printing PLA. The problem is printing PLA overhangs because the cooling's not very good. You'd have to keep the doors open all the time, and even that can be a bit limiting. I mean, you could just take a panel off or something like that. I mean, it wouldn't be the end of the world. Most of the problem with printing PLA is trying to keep it cooled with plenty of air. So Stealth Burner should help that, or the ABBN, but now you might as well do Stealth Burner. And just keep the doors open. And then PLA is pretty much fine. You just don't expect any serious overhangs and try to avoid bridging as well, really. Excuse me. I can send you a 0.8 nozzle if you like. That's a very kind offer. If I get round to actually putting one in a printer, then I'll contact you. If I end up busy with other things, then I don't want to take away anything that you've got at the moment. So, but I'll keep in touch. Thank you very much. Tell us about the V-Core 3 upgrades. I'm not. Upgrades is a very confident word to use. Flow rates during printing is difficult. You need a special model. The fact that up till now, it seems like, well, from my test rig, it feels like we really didn't know anything about flow rate. This is bizarre, this thing. And the fact that we think we know everything, or we think we know a lot about all of this stuff in here, and we can't even push plastic out of a bloody nozzle without we know what's going on. It's a bit like flying planes. There's still debate in the finite details of how a plane works, how wings generate lift. We know they do. We know how to make them better. We know how the shapes and stuff and how to control them and how to build the plane. We don't know exactly why it works. That's kind of the same thing with some 3D printing bits. We know we can push hot plastic out of a nozzle by starting to melt it. The harder we push it, the more we can get out. And we can push it faster. But now we know force. The force unlocks all. Oh golly, comments are going fast. How long are we in? Nearly an hour and a half. Do we want to, who wants to talk about, I was going to do Klicky install. That's probably going to take a while. Who wants to look at some RatRig CAD modifications that I've done? Oh, there was one other question about why bright zinc plated fixings, so BZP fixings or BZP fixings. There's a comment about BZP doesn't make them stronger and that blacker hardened steel. All of these things might be true, but for my preference, the black self-colour ones tend to just corrode. Even with the slightest amount of moisture over a couple of years, they tend to corrode, even in indoor environments that are just mildly moist. Whereas bright zinc plated are not going to corrode inside, they're magnetic, so better than stainless steel because you can actually use a magnet to stop them falling off the end of tools, and they're super widely available. And if you get them from a decent supply, they should be a pretty decent grade. My solution to corrosion was to move from the UK to California. Yeah, that seems like a good budget accessible solution to that problem. Yeah, that's my recommendation from now on. If you're having trouble with corrosion, don't change your fixings, just move house to a completely different side of the world. There's one other thing that I mentioned in the video, and that was about turning the Raspberry Pi on and off. So I think this is going to be my solution. I might make a video on it separately. Which is basically one of these kind of Arduino style 5-volt relays in a box, and you can control that just with like a switch on the front of the printer. You can actually see it on here now. I made this little mod that you press a switch in the front. It's not actually installed, there's nothing connected, but it's just some little clips that you can push in the front and install the switch in. And then you connect that switch between the 5-volt power supply, which powers the Pi, and this relay. And then this turns the mains on and off via a little switch on the front. So you keep the 5-volt power supply powered, and that keeps the Raspberry Pi on, and this just turns off the main control board and therefore the lights and everything else that's connected to that. I might do a double relay option to have one for the 24-volt power supply and one for the SSR, because otherwise there's potential, I think in some weird quirky scenario, that the control board turns off but the SSR doesn't respond correctly and remains on, whereas a secondary switch would then immediately and always cut power to the SSR. So That's that. Should be really easy to do. No special software, no Wi-Fi, no configuring. You just put it in, connect it up, switch on the front, does everything you need it to do. Nitpicking, but the zinc plated steel corrode. It's just the zinc corroding first, not the steel. Well, yeah, but zinc's way more corrosion resistant than steel is. In a normal home, you're not going to get zinc corroding to a point where it matters. So did anyone want to see the RatRig mods? Nobody said they wanted to, so I'm assuming nobody wants to see that. Let's see if we can cover some more questions. Here's one. One of the comments on the video was, what I'm taking from this is I'm right to wait for the Prusa XL and see what that brings, as the price I think will be a complete printer and better supported than the Voron or the RatRig. That's one of those questions. Oh, okay, you do want to see them. I must have missed your answers. Okay, we'll do that in a second. Yeah. Prusa XL, it's not released yet. The price is quite high, and it's not released yet. It doesn't exist, and it's not released yet. But apart from that, you can wait for as long as you want, and there's always going to be something better coming. The fact that you can't buy one now means it's sort of, well, I tend to leave it out of comparison because it doesn't exist. Well, it probably does in the Prusa factory, but not here. I can't get one. No normal people can just get one. Okay, let's go through Voron or Prusa XL. Why? Voron because it exists. Okay, I've not gone through this. I've not got much planned. It would be good for you to test Orbiter versus LGX Lite. I'm one step ahead of you. Beep, beep. That's an Orbiter 2. It'd be good for me to test everything because that force extrusion thing is just the best. So, here we go. So, there's a lot of changes here. I've tried to use, instead of looking at the keyboard because there's no point, I'm going to point it at my face, which is just weirdly zoomed in. So, I've tried to keep many of the original parts, but also changed quite a lot of things. I don't know where to start. So, in terms of goals, I wanted to make the frame a bit easier to assemble. I'm reading a list. I wanted a rear panel to cover the electronics. I wanted fewer frame pieces around the extrusion area, which I pointed out earlier, and I'm kind of utilizing a Voron skirt, but on the back. I'm going to Joel-telling the front crossbeam, so just take that front crossbeam out. Fewer malleable extrusions. The simpler top hat enclosure. So I've tried to reduce the number of extrusions because reasons. I've tried to make all the side panels not require any cutting. So as I mentioned earlier, just like complete rectangular shapes. I've tried to keep as many of the original parts as possible. So, I mean, I've not been tremendously successful because there are a couple of parts that you can't, well, you could make them, but they might not be very precise. Anyway, I've tried to keep as many of the original parts as possible, so you could still buy a complete original kit from RatRig. and then just print your own parts, and you could print this set of parts instead of their set of parts and build what is essentially the same printer, but with lots of modifications. I'm also planning to add in a super pinder and the new RatRig idlers, which I still have not installed. So this CAD model is a bit of a mess, so I do apologise in advance. So let's look at the main printer to start with. So you'll probably notice immediately the front crossbeam's gone. So that's obviously where you'd have another one of these extrusions. It's the same length, so the same length is used in all these different places, and you can just take it out. I've got a temporary placeholder in the model for just moving it down, which could be an alternative option. I'm not sure how I'm going to like that, but doing these mods is more about trying different things rather than going, oh, well, this way is going to be better, because I don't know that it's going to be better. I don't really think that at all. I just want to try it because it could be interesting to do that. Obviously, I think there's a chance it would be better, because if I thought it was going to worse, if I thought it was going to be worse, I probably wouldn't bother at all. But I don't think there's any guarantee that it's going to be I can't say that word. If there was any guarantee that it was going to be worse, then I probably wouldn't try it. It looks flimsy without this in, and it might be, but it also might not be. It just looks less, but less doesn't mean it's not going to be enough. So these again are part of adding in some rigidity. Obviously the problem is with this open, these can obviously move in towards each other and oscillate, vibrate, all that kind of stuff. So these are again kind of placeholders just to remind me I need something that's going to brace that corner a little bit. The whole XY is kind of the same. This whole X carriage rail thing is all basically the same. The rails are in the same place. The idler fronts are just a bit different. They're just kind of filled in this space, but all the metal plates are just the same. Towards the rear, I've flipped the plate around because I've removed the extrusion along the back. So again, this part is a little bit shorter. It doesn't attach at the back, just attach at the side and to the metal plate. And the metal plate is going to be providing most of the strength in this scenario anyway, so I don't think that's going to cause much difference. Mirrored that to the second side. Sorry if I'm spinning this around a bit much. And then the back, again, those 4 extrusions around the rear, which probably not doing very much. I've tried taking those out and filling it all with skirts and a panel in the hope that that'll have, I mean, it takes a lot of plastic, I'll give you that. But I think it looks kind of cool and should work quite well. It might be a bit wobbly, who knows? Red Ever's blasphemy, sorry, yeah. I should have changed it back to green. The only reason it's red is because when I was doing some mods like on these, the hole pattern things that I did on these, so I could print them face down without having to punch holes out, I coloured the parts that I know I'd done, so I didn't try and do parts twice, and I forgot to put them back to green. Sorry. I did see the internet's mod, yeah. I'm missing all these questions. The lack of corner plates is the best bit. I think I spent most of the first episode of my stream just putting in screws for those corner plates. Let me show you what I'm going to use on the joints, because I've got it here. I mean, this is all kind of spoilers for what was supposed to be a live stream, but so these are the connectors that are used, obviously different size ones, but they're what's used on the workbench. So in the end of the extrusion, you have a hole, and you put in this thing here. It's really difficult to do with. It's easy to do when it's kind of stood up like this when you're just doing it, but if you've got to show someone, it's a bit more difficult. So it kind of pokes in the end like that. That aligns to that hole, and then you shove this thing in the end. Ooh. Like, honestly, it's really easy when you're doing it just by yourself. I've not really set up to do this. Is that the right one? Yeah. So then to tighten it, you just kind of tighten this, so pull that out and pull that out. You stuck that in there, you shove this in here, you screw that down, you tighten that, and you've got yourself a basically perfect 90-degree angle, which is super bloody rigid. It's like IKEA furniture frame. I really like it. You might think it's silly. I'm sure it's not as strong as a massive corner plate, but I want to see if it works. I think it's much, much faster, that's for sure. I don't think it's much cheaper, unfortunately. If the extrusions are not cut square, then you've bought them from somewhere you shouldn't have bought them from, because cutting extrusion square is so easy. Well, so easy in the fact that there are many places which can do it well, and it's not expensive to get done properly. So yeah, if you were cutting them at home by hand, you don't want to use these connectors probably. But if you're getting them cut to length by a machine shop, then it's probably pretty good. Exactly, it's as precise as you're cutting, and I can guarantee that pretty much 99 times out of 100, that is going to be much better than your ability to assemble it square by hand without any jigs or like stiff other things to get everything aligned. Which is why I really want to do this, get this frame together. Try to break the joint, no thanks. I don't have any spare extrusions. I mean, it's holding up this entire blooming workbench, like, they're strong joints. Cutting extrusion square is incredibly easy, and it just comes apart like that. It takes maybe 10 minutes or something to put all these little things in all the holes. You could do that as like a first assembly step, you've got them all ready, and then all your assembly is literally just slot it in, screw it. One screw, joint done. It's glorious is the word I'd use. But obviously, all of that counts for nothing if it makes the whole printer really, really wobbly. Which we don't know yet. Well, I don't know yet. It might do, but until we've tested it, we shan't know. This can be quite expensive. Different places charge varying, like massively different amounts to stick a blooming hole in the extrusion. I've actually done a couple of these using a jig. Jigs are my new favourite thing. I am converting the whole printer. Did I show you the jig? I'm showing you all the spoilers for my live streams. I've been a busy boy. I mean, it doesn't exactly take long to model in CAD, as you can tell. So this is a jig. This is a specially purposed drill bush. It's hardened steel and designed for you to put a drill through and make a hole in the right place. And you simply put that, clamp that, do your drillies, take it off, job done. It's pretty slow. It's not the fastest thing in the world, but this and one of these, this thing in here is only like £2–3 or something. So normally they charge maybe something like £1.50 or something just to have a single hole, which sounds like a lot, but then you don't have to buy any of the plates or screws that you would have had. So I think this jig could probably do with some improvement. It's a bit too long. I printed it in the wrong material, so it's kind of split a bit. But just being able to clamp that, stick that on there, clamp it on, and just drill, bosh, straight through. And it's worked amazingly well. I only used a single clamp, zoop, hole. And the hole doesn't need to be super precise. It obviously needs to be pretty square, but this is plenty good enough, I think. Seems to be so far. And doing this bit is kind of trivial after that. Just jam that in there, jam that in there, job's good. Piece of piss. Apart from I've now got bits of sharp aluminium dropping out the ends. What's this 2 years European warranty? What's that all about? You hand drilling or drill press? I used a drill press. Because this is quite a large drill bit that you need. It's like 11mm or something. I think my hand drill will only do up to 9 or 10. So didn't fit. So drill press was the only way to do it. And my cheap drill press is not very great in terms of travel or height, so it only just managed it, but it did manage it. So yeah, there you go. You now know all my secrets. Well, not all of them, but some of them. There's still many more secrets. Let's go through some more of the mods. Standard EU consumer warranty applies to RatRig parts as well. I don't think that applies to kits though, does it? I mean, I'm guessing RatRig will have checked, but I thought that's why a lot of companies, Chinese companies especially, provide kits, because you don't have to provide the same warranty. You probably do it at part level maybe. I don't know. So what were we looking at? So yeah, that's what I've put at all the corners around here. Well, around everywhere. That doesn't need to be there. And then a lot of this backside is kind of just plastic. All this kind of stuff around here. I changed this pass-through bit. This part was very difficult to print and be strong. The one that came with the printer actually snapped when I put it in. There's not a great print orientation for it, so I tried to integrate it into a way that will be sufficiently rigid and easy to print. So obviously this side face down, and then you get this nice little hex pattern on the inside and a decent place to put all your cables, zip tie them all down, that kind of thing. All the idlers, I mean all this geometry that kind of looks like around the idlers and pulleys, that's all the same. The plate The difference here is that the motors are moved in. So in this standard design, there's like a 4mm gap between the extrusion and the motor, so you can put the panel in between them, which was a difficult decision for me because obviously I wanted to make sure all the panels were just squares. So that was one of my conditions. But knowing that this panel has to have lots of holes and stuff for the mounting, and then pass-through holes as well, it's like it's going to have holes. We're probably going to do them by hand. So if we have to do a bit by hand on here, it's not going to be the end of the world, and you're never really going to see it. So I decided to cut holes in that panel, and I don't know where the panel's gone. It seems to have just disappeared. There it is. So I've just kind of, it's like super basic, probably doesn't even need this bit over here. I've cut that out so that allows you to move the motor in, and you can use then the same plate. And you can also mount the motor and stuff without having to worry about putting this plate in. If you forget it as you do everything, it doesn't matter, you can just add it in afterwards. The other nice advantage of this is because there's nothing's like completely enclosed by the frame, you should, in theory, be able to do like all of this assembly of this motor, all of these parts, the idlers and everything away from the printer. You can do all that stuff away from the printer, or just like at an optimum angle in front of you, and then mount it once you've got all the idlers and stacks all kind of aligned, rather than having to like turn the printer over and lug it around each time you want to put something in, and then kind of clamp it around the extrusion. So yeah, that's why that should help that. I've also changed these on here a little bit. So I believe if Pavel's still here, he might be able to clarify this, but I think the only purpose of this part is to hold these bolts in place as you assemble these stacks. Because it keeps the bolts pointing directly upwards while you put all the parts on the top, so you don't have to hold them up while you're stacking things and then accidentally, like, it could just all become a nightmare. I think that's what that part's for. I think that hole in the middle is just to reduce material. So, I'm not sure why I put that there. That chamfer seems pointless. Anyway. Yeah, I've kind of changed it so you can print it differently. What was I doing here? That presses onto there. Oh, so you can remove it afterwards. It doesn't have to stay there. And you can now clamp that bolt directly down to the plate. So before, I didn't over tighten this too much. Because you've got plastic at that interface, that bolt can go way tighter than that plastic can handle. So if you try and tighten that plate down, which is, I think, the most critical part of mounting this motor, if you tighten that screw to its maximum torque, or to even what I would consider maybe like a good level, it's a bit wishy-washy, but if you could, the more you torque down that bolt, the more you're just going to crush that piece of plastic and either destroy it or just it'll fail over time or something like that. So I wanted that bolt to make contact with that plate or with the washer or something in the middle. So like this, you should be able to do that and hopefully press that onto there and hold these in, or just assemble the whole thing without it, because you can do it off the frame. Maybe, hopefully, that's the plan. So they don't slide. Keep the screws in place. I assume by slice you mean slide in XY. So, I mean, in this orientation now, this piece, this metal plate, will index completely against this extrusion and this extrusion. So, you literally put it on, shove it into the corner, and bolt it down on this face here, and that's completely set that position, those screws can then just go in. Their precise position shouldn't matter too much. Oh, I guess the position of these bolts, because they could move. Is that? Yeah, we'll see. Maybe it won't work quite well. Okay, yeah, I see. So it prevents that head from moving around here weirdly, because there's obviously, you've got to be able to fit the screw through the hole, and all those tolerances mean that it's going to move more than you want it to for an idler. So you can put this piece on and it holds that head in place. I wonder if now that you can clamp these idlers a bit tighter, if that will still be a problem. Obviously with the original ones they were crushable, now it might not be so much. Well, either way, that part should still function the same in terms of press fitting onto these screws and holding these screws in place. It just also means that this can have metal to metal contactor here as well, hopefully. Yeah, I see what you mean. Yeah, you've got to hold that head in place, otherwise your idlers go, yeah, totally wacko. I think it should still provide the same, or at least similar, and it's press fit, so it should still work. But I think it should, yeah, as I said, the most critical part I thought was, well, the main focus of my change was to try and get that metal to metal so you could really hold that plate in place better and make sure that the motor and stuff doesn't move. We'll see. Again, it's just kind of trying things, see what works. And obviously because this, because I put this whacking great hole in this panel, I just made these extra plates to go over the top here. A little bit of style, a little bit of a hole because this side's got a hole, and it just covers the hole and looks really cool. That's about that. The wiring, for some reason, so wiring's a whole nightmare on its own. It's something I tried in the original build, or commented on, was that it'd be really nice to not have to cross any of the mains wires with the low voltage wires. And there wasn't really a way to do that because the power supply was on this side with the IEC connected down here, and the mains comes in over here and the low voltage came out here. So it comes in here and up to here, and then out the power supply comes this way. This is actually control board, that's the power supply, but it was on this side. So they'd always be crossing. So I wanted to try and put it in a way that you could do it so there was no or very little crossing. So I've moved the power supply to this side. Mains will come in on this side, into this side of the power supply, and low voltage goes out there. Obviously you've still got other power supplies which are kind of close, but maybe a little bit not so bad. Anyway, power supply's on that side, so I moved the mains wiring to come, this clamp to be on this side, that hole is on the other side. Mains wiring all is on this side, and the low voltage stuff is on the other side. That's really annoying, the amount that flashes, isn't it? That's probably even worse. This is one of those things that as I was doing it, I was like, I'm changing way too much for this to be worthwhile. It's like, it's the most minor thing, like, oh, the mains gets a bit close to the other wiring. It's just like, it was such a tiny thing, I was like, well, I've kind of done it now. But I mean, I've not really changed, as in, I've not actually done the CAD modifications. As you can see, I've just kind of drawn this pattern on the back and put this hole in. Like, if I just printed this part the other way around, there's no change. So This part is actually basically unmodified, it's just flipped across. Hello! People just joining. You should do Ventimec arms instead because they're cool. I quite, maybe. So as part of removing this crossbeam and potentially having these supports in here, I obviously needed to move the rails. So I've moved the rails for the Z around to this side and then just basically moved the arms. This is in the same place, the nuts in the same place, the axles in the same place. It's just rotated. So my concern is that the weight of the bed is going to cause this to rotate. So I've tried to put in some sort of anti-rotation things on here. I'm not sure it's going to be enough, but the load should be going, the vertical load should be going mostly through this lead screw. And provided it's clamped strong enough, it shouldn't really slip. And that's also quite secure in there. And even if it does droop a bit, as long as it stays like that and doesn't move around, we should be okay, I think. Not ideal, but the bed leveling should compensate for that. But I don't think it's going to be a problem anyway. I think that's going to be okay as that. And then that's kind of it for the main part. For the main enclosure, I've added these kind of Voron style clips. Oh, it's starting to rotate weird. I've added these kind of Voron style clips. So the panels, side panels are both completely square. There's no holes, no cutouts, no nothing. So some screws through there into nuts. Oh golly, the zooming's going all over the place. Sorry, going to make people dizzy. So yeah, these kind of Voron style clips. I've adjusted the hinges just a little bit just to clear this panel, so the hinge now mounts directly to the frame rather than sandwiching the panel, so you don't have to do those cutouts. The front I'm going to stick on with VHB tape rather than screw through the panel, because obviously then you don't have to put holes in the panel. And screwing, if you have acrylic, I always find there's quite a big risk of just absolutely cracking the panel if you try and drill holes in it. So not something I really want to try and DIY or would recommend people DIY. Obviously you've got like die bond panels and that's solid front door, then you'd be fine. But a bit of tape I think will hold this door just fine. I mean, the doors on the Voron have tiny hinges and they're held on with a tiny bit of tape and they're absolutely fine. They've not got to support anything other than the door, which is not heavy. Again, rear enclosure uses a kind of Voron style clip at the bottom here. I've put these holes on every single panel and these are sized for threaded inserts. So your normal N3 brass threaded inserts. You don't need to use all of them, I've just got them everywhere. So because you can put obviously these panels on either side, so it's kind of modular. These are like 100mm and there's 50mm ones. The LAN connector's 50mm, but if you're just doing Wi-Fi, you don't need that. So yeah, it's just like 100 and 150mm modular. And if you had the 500, obviously you just put in another couple of 100s to make up your extra space. The handles at the front, I can't remember what the original ones looked like. Oh, they were like actual handles bolted on the front. So again, trying to remove holes and just replace them with things that can be just stuck on and held with magnets. So same sort of magnet idea in here. Same as the original design. Well, similar-ish to the original design. Hundreds of magnets, and then you've got these which are magnetic and stick to the front panel, and there you have a nice square front panel. In the top box, if we try and hide the other, we can kind of look up into it maybe. It might be best to maybe isolate this. So for the top box, I've tried to remove some of the extrusion. I don't think, well, I've obviously not tested this, and I'm sure other people have, but this is going to add weight. I don't think, even if this is at maximum rigidity, it's going to help the rigidity of the printer itself. So it doesn't seem like there's much to be gained by having it incredibly rigid. I've kept a lot of the frame in here around the top, but taken the ones in around the bottom and used some like locating pins at the corners to interlock into the main printer. Again, using printed parts where possible and the original screws, so everything's dimensioned for the countersink screws that come in the kit. I, in this instance, have actually reduced the length of these just because I fancied it. It looked weirdly tall. Still fits the full spool holder, same design spool holder, same length, same parts. Again, all the panels, just rectangles, no extra holes in them. Everything just locates appropriately. This edge looked a little bit close because if you've got these hinges here, you can't come all the way to this edge like you normally would. So there's only like 2-3 mm overlap. So I've just added a printed part in the base, which comes in and just assures that you've got something to clamp this panel against, so it's not floppy all over the place at the back there. And then this guide is exactly the same. These are exactly the same. It does reduce potential for moving this up and down. I'm not sure, having not much information about this gas strut. I've just realised I've bolted that to that. That's not going to work, is it? What's going on there? You just don't need these two clips. You need another one up here probably. Anyway, it doesn't matter, it's just a tiny thing. Yeah, I don't know, because the instructions for installing these gas struts are such that you kind of tune their position. So if you're moving this up to here and this out to here, you're changing the leverage available at different points. So if it doesn't stay open or it just forces itself open and doesn't close, for example, you can adjust that just by moving the ends in and out, up and down until it meets it. I'm not sure how much of that is needed, so I've restricted it quite a lot in the hope that not much is needed. Unfortunately, because I've removed a lot of the extrusion, it's going to be a lot lighter, but that should mean that this can move up more as it doesn't need the same amount of leverage. That's the plan. So yeah. That's kind of it. At the end of the day, all the bits that I felt, oh no, there's actually some more bits. So on these main enclosure panels, this enclosure panel is normally on the other side of this extrusion. It's normally above, and that's obviously designed to keep the motors separate from everything else. While keeping the motors in the same position, I've moved I basically added plastic to the mount to align to the panel at the base instead, to try and reduce, so two things. It reduces hopefully the amount of corner cutouts that you have to do, because you don't have to do the runs at the rear, but you do still have to do this. I was tempted to make this square, which would obviously be a lot easier to do by hand. You can probably just do it around the motor and make this bit shorter. That's probably a good idea. But that motor is technically still outside the frame rather than inside, because these are all kind of sealed up against the extrusion. Yeah, hopefully that should make that panel easier to fit, because you don't have to put it in and kind of jam it in around the motors and stuff and take the motors and stuff out. You should just be able to add it in at the end after you've done everything else. And I've added in these slightly different feet. I needed something that obviously threads into the end of the extrusions, which is very easy to do. Well, should be pretty easy to do. I've got a tap. I've not actually tried tapping the ends yet. So you can just screw and make countersunk or something into the end there. And this is where the switch will go to control the power, the 24-volt power supply to turn off the control board, lights and fans, etc. So yeah, it's not 100% complete. Oh, there's one other thing. This is not necessarily something I will do, but I had an idea of putting a aluminium plate, because I've reduced the thickness of this quite a lot. I've dropped it down. I can't remember why. Why did I do that? Seemed like a good idea at the time. There's still plenty of space at the top. I tested that the nuts don't go off the top of here. But I move this down. The motors are moved lower. They stick out the bottom. It might have been so the connectors can come under here. Oh yeah, the plan is for these, because this is countersunk, so there's going to be a big cylinder here. So I'm probably going to make just a kind of printed TPU cylinder. It'll stick out the bottom, hopefully compress a bit. I don't know how slidey it'll be, but maybe if we texture the design of the TPU slug, it can maybe provide some damping and some adhesion to the thing. The other alternative was to try and find a way to put an M5, the original M5, I think it's M5 or M6 threaded feet on. But the original ones are quite hard anyway. Would need still some extra clips and stuff. I've not modelled those in for mounting wires and things, but yeah, this, but did I finish saying that? Yeah, I wanted to kind of make this a metal plate, like the other aluminium plates, to improve the strength of these mounts. I didn't do it here for some reason, where it's actually most important. But yeah, I literally just kind of cut a slice off the top and made it black, just to remind myself that an aluminium plate could be a good thing to put there. Or even steel. Or you could just print the entire feet in TPU. Yep, that's another good point. So yeah, I think that pretty much explains it. Yeah, so this doesn't have to mount on there. You've got the little magnets. I mean, there's a lot of changes, but it's still a V-Core 3, I think. All the parts that made it a good V-Core 3 are mostly still there. At the end of the day, if I had to put that cross beam back in the front, it probably wouldn't be the end of the world. Maybe what I need is just some end G-code thing that brings the bed down after it's finished, because it's normally, it irritates me most on when I've done a small print and I can't get the bed out. Yeah, I think the schedule for today's video, because I was originally going to do this in December and then just made the video private and didn't delete it. I just made the same old one and rescheduled it. So I think YouTube was like, well, this is a video from December that's being played now. So it didn't show up in like the current thing until it was live. Or presumably it shows up in the current videos now. So yeah. Hopefully that explains most of my thought process on modifications. Obviously I've not done any of them yet. I've printed quite a few of the parts. So things like these bits which hold the panels on the back and provide you that kind of hex design. These corner bits that just kind of fill in and match up obviously to anywhere where there's hexes. More hex pieces, the slightly different AB motor mounts that are a bit slimmer and therefore designed to fit. Once you've assembled, you can then kind of fit it on the end of the extrusion like this and mount it, rather than having to kind of clamp it round and assemble it directly on. These little locator pieces which I showed you from the top lid, which were these pieces, which I've mentioned, talked about a lot. I've slightly modified these, made them a little bit wider, just so you can move the NEMA motor around a bit. Idler mounts, so that will obviously socket into there. Seems to fit reasonably well. So when the lid comes down, that'll just sit in that and kind of locates and doesn't... I mean, it wiggles a bit, so maybe you could improve geometry there, but it's good enough. Made a little jig because this is just some alignment stuff, so just something that fits in there, gives me a good distance, just because there's a couple of bits in the assembly that need to be in the right place. Same sort of jig I made for, what build was that? I think for the V0 I did those. These are the bits that hold up the top of the roof, top of the enclosure. LAN connector. I'm not really using the LAN now. This is the door handle, so you've got magnet hole in the back, and then just put some tape over the top. This aligns it to the bottom of the door. That edge aligns it to the middle. That just goes on. Little door handle, obviously cut out so you can kind of get your finger behind it. Part of the motor mounts. Does this one go with this one? Not sure. Looks pretty neat in yellow. I think with lots of black frame and stuff around it, you get a really nice contrast. It looks a bit weird on camera. It looks a lot brighter than it actually looks in real life. These got kind of white, but that's a bit of heat will remove that. So I've got some alignment parts on these, so you don't move this around anymore. You keep that in place and you move this around on here. And from my testing on what I've got for this prototype, it seems to be sufficient. And then this alignment assures that this goes in basically the right place. Obviously that goes into the corner, and the other, once it goes on here, that all goes in pretty nicely. We now also don't have to have really deep holes in these sides because I've brought this top down. So it's just a nice straight hole. That's really nice. Happy with that. I'm not sure if this is going to work, but I made the end stop switch into a single piece. I don't know how much people have used the translational movement, but I didn't really change it. I found I just kept it in the middle and just left it there. So maybe other people will need to use the old design still, but I wanted to try a different one. For some reason I printed that in yellow and in black. These are the arms. So big, beefy, should hold onto the rails because I've hopefully tuned that just right. And this is just nice. Of course, all the holes have got like hole treatments, so you don't have to punch anything out of the holes. You don't have to drill them out or anything. You can just get them straight off the printer and use them straight away. This is what the kind of clips look like. So there's one back panel one. I should try and make the same design really. This is like rounded and this is chamfered. And this is the wrong hole size actually. This is one of the inside corners. It covers the corners in the back panel for the motors. Anyway. Any questions? I've just blabbered for like half an hour or something. Got the hinges as well back here. So again, pretty much the same design. I've just adjusted this place so it doesn't have to use a panel, and taken the holes out the front so we can just use a bit of tape to hold the door on. Obviously I've not put a screw through it yet, but that'll work just fine. Corner clamps. Again, I've modified the design now. This was when I was going to go with the M5 screws or something, or M6 even. I was just like, no, that's just totally unnecessary. So little M3 screws be absolutely fine for that. But that's all that. Yeah, there you go. That was a lot of blabbering, wasn't it? Is anyone still here? Get rid of this pieces of aluminium before I cut myself on them. Right. there's not any more questions, I think we'll probably call it there for today. I'll do the Klicky Probe another time. I might just do it off camera. I think it's probably pretty easy to install, isn't it? Not sure it really needs a video. Does it? Maybe it does. We'll find some time, maybe at the weekend or something. Bye, Pavel. Thanks for sticking around. Hope you enjoy your working. You must be... What time zone are you in? It's like 9:45. I thought Central... Huh. Have you ever done any printing in polycarbonate with the 2.4 or V-Core? I want to print a better filament than PLA and ABS. I actually haven't, really. Time to start getting the real work done. Yeah, to be fair, I know that feeling. Yeah. I've done the same. I did most of the extrusion, force testing, rig and designing stuff late at night. Everything's like quiet, there's nothing else going on, there's no like email spam or anything like that. You can just kind of get on with stuff. I've not even gone through any of this stuff that I've got sitting here. I guess because you guys can't really see it. Got a bag of this. So this is all the parts. I've bagged all the parts so I know that I've got, like, this is the whole bill of materials in theory. There's no magnets. I think I've got the right magnets though. 6x3mm. Is that the right? So that's all the parts for Klicky Probe. I bought all the stuff for Nevermore, so I've got fans, got the ABS parts, got the trays, got the magnets, got the fans. So that's got all that to do. And obviously this is the activated carbon stuff. Got the power switch stuff, which I mentioned. This is the GE5C, so uses special, what kind of bearings do you call these? Oh, I forget the name. But they improved the pivot points on the corners of the gantry, because at the moment that's just like a printed part, so the bearing interface is not very smooth. So these, let's see if I can show you one. These kind of replace those corners. This small camera in the corner is pointless, isn't it? Because it's no bigger than the actual main frame. So this kind of pivots around, so if I push on one side, ooh, you can see it kind of now points in that direction. So they're reasonably stiff, but that rolls around that. So that should allow the gantry to... Yeah, GE5C, yeah, but it's not, that's the model number of the bearing. It's not the name of the type of bearing. I want to say like a convolute joint or something, but I can't remember the blooming name of it. There's no point in me trying to think of it now, I'll just... It's too painful. So yeah, that's another mod. I've got orbiter extruder, I mentioned that earlier. CHT nozzles to try. Also some alternative fans. So a 5015 for doing stealth burner and some more 40mm Xenon fans. 24 volts. One goes front of stealth burner right for hot end, cold end cooling side. That's all the stuff I've got at the moment. Spherical bearing. That'll do. That's a good description, even if it's not the right one. Right, I think lots of people are leaving, so I think it's probably time to call it a day. It was a good little chat. Hopefully it's been useful. We've answered a bunch of questions, so hopefully anyone that does have questions later won't have to ask them in the description of this video, and they've been able to ask them. No, it's not going to happen, is it? There's going to be loads of questions in the comments. Well, there you go. Hopefully it's at least answered some questions for those of you that had them. Now it's time to move on for more extrusion testing and to mod the hell out of these two printers. Yeah. Wish you would have clipperized the duet as a tutorial. It's just... I just wouldn't buy a duet to clipperize it, because, I don't know. Maybe I will, probably won't. Probably won't be doing another hour-long comparison. That was a lot. Right, yeah, thank you everyone for joining in. Hopefully we've answered the questions that you needed answered. If you haven't watched the Extrusion Force testing video already, I highly recommend you go and watch that. Probably one of the best videos I've ever made. There's a lot of graphs in it, but the information is mwah! So it's definitely worth watching. It reveals all the things. So that's going to be it for me today. Thank you very much. I'll see you in the next one. Goodbye.